An auto insurance company insures drivers of all ages. An actuary compiled the following statistics on the company's insured drivers. So each age range had a particular probability of an accident, and we also have what portion of their drivers are within each of these ranges. So a randomly selected driver has an accident. Find the probability that the driver was in the 16 to 20 age group. So just kind of looking at this without actually doing any math, you can notice the 16 to 20 age group, it definitely does have a higher proportion of higher probability of accidents. It's not proportion, it's probability. They're actually twice as likely to have an accident as somebody in their 20s, and 3 times as likely as somebody between 30 and 65. But if you look at the probability that this random person is in that age group, only 8% of all drivers out there, according to these statistics, only 8% of all drivers out there are within this age group. So you can see there's kind of some competing. They're more likely to have the accident, but there's fewer of them out there. So that sort of thing is what makes this type of question more interesting. So let's define some events. Now, I have 4 different age groups, and in each of those age groups there's a probability of having accidents. So I'm going to say A1, A2, A3, and A4 for the different age groups, and say, okay, what is the probability that you're within each of these age groups? I'm going to say the probability that you're within age group 1 is, well, the portion of all drivers is 0.08. The probability you're in age group 2 is 0.15, age group 3 is 0.49, and age group 4 is 0.28. You'll notice this probability right here, this is saying if you're in this age group, your probability of an accident, I'm guessing this is during a year or something, I'm not sure exactly how it works, but the probability of an accident, given that you're in this age group, is 0.06. So we're saying the probability of an accident, I used A already for age, let's say C for collision. So the probability of a collision, given that you're in age group 1, is 0.06. The probability of a collision, given that you're in age group 2, is 0.03, and so on. Probability of collision given age group 3 is 0.02. Probability of collision given age group 4 is 0.04. Okay. And notice it starts to go back up there for people who are over 66. Interesting. In any case, if we're trying to figure out, what are we looking for in this? Find the probability that the driver was in the 16 to 20 age group, given that they had an accident. So randomly selected driver had an accident. We know that they had the accident. So this is given a collision. We're trying to figure out the probability that they're in age group 1. We're trying to find the probability of A1 given C. You'll notice all of these are written the other way around. They're all C given A, one of the A's. So that's how we know that this is a Bayes' theorem problem. And let's see. I'm going to split my tree up to have 4 different branches because I have 4 different age groups. So the probability of A1 is 0.08, A2, probability of A2 is 0.15, probability of A3 is 0.49, and the probability of A4 is 0.28. And each of those, I'm not going to bother, well, okay, so each of these would split off. We'd have a collision and a non-collision. So I'm going to say the probability of collision given A1 is up here, and the not having a collision, I'm kind of not worried about that part of this tree diagram. I'm just going to leave it because it's not really what I'm interested in here. Probability of C given A4. All right, so we had, what were the numbers here? 0.06, 0.03, 0.02, and 0.04. Alright, now I can figure out my branch probabilities. So the probability that they are in age group 1 and they had a collision, so the intersection there would be the product of these. That's my product rule. So 0.08 times 0.06, which gives me 0.0048. This next one we have 0.15 times 0.03, which gives us 0.0045. This next one, 0.49 times 0.02, which is 0.0098. And then we have 0.28 times 0.04, which is 0.0112. All right. Again, we're trying to find the probability of A1 given C. So this value right here is the probability of A1 intersect C divided by the probability of C. It's always the intersection, or when we're talking about these conditional probabilities, it's always the probability of their intersection divided by the probability of the condition, the one that followed the vertical line. So A1 intersect C, I actually wrote it down up here, is 0.0048. And in this case, the law of total probability says the probability of C, we actually have C happening in 1, 2, 3, 4 different branches. This is C given A1, C given A2, C given A3, and C given A4. We would have to actually add all 4 of those values together to be able to get the law, the probability of C here. So we get 0.0048 plus 0.0045 plus 0.0098 plus 0.0112, which gives us, I'm going to add those up first, 0.0048, 0045, 0098, and 0.0112. Adding those together, we get 0.0303. And when we actually perform that division, we get 0.0048 divided by 0.0303, which gives us approximately 0.1584. So the probability, we heard an accident happened, the probability that that particular person was from the age group, this youngest age group, the 16 to 20 age group, was only about a almost 16% chance.